I want to talk about is what kind of equation looks like a line. Actually, I guess that's not the first thing I want to talk about. The first thing I want to talk about is what it means to graph something. So a graph is really a visual representation of all the solutions of some equation. For our purposes, it really means something else in math, but that's how we're going to be using it. So if I have an equation like this, say y equals x plus 2. Now, I've got two variables, so that equation is not solvable, right? That is as solved as it's going to get, because if I pick a particular value for x, I will get a value for y, and vice versa. If I pick a value for y, I'll get a value for x. What that means is there are an infinite number of solutions to this equation for different x's and y's. For every x I pick, I'll get a different y, right? And I can pick whatever x I want. So for instance, I can make this little chart here, which I imagine you've seen before, but if you haven't, there you go. It's called an XY chart for obvious reasons. And then I pick a value for x. So if x is 1, y is 1 plus 2, which is 3. If x is, say, negative 3, y is negative 3 plus 2, or negative 1. If I pick a value of 0 for x, always a good choice, by the way. If you have an opportunity to pick something, pick 0. Almost always the easiest one to find, and also very often the most interesting. So 0 plus 2 is 2, and I've got 3 points there. And so the way we're going to represent these, and I imagine you've seen this before, but just real quick, the way we're going to represent these visually is on what is called a Cartesian plane, named after René Descartes, a French philosopher and math tutor, who is supposedly, like it's said that he came up with this idea. So Descartes was a pretty sickly guy. He was ill a lot, and he was a really famous tutor, and he was tutoring a rich person's son, I believe. And the ceiling was tiled, right? It had a bunch of squares on it, and Descartes supposedly realized while laying in bed and staring at the ceiling all day that he could identify the position of a bug on the ceiling just by saying how many squares it was from a certain starting point, right? How many squares it was in each direction. Now, we typically call these the x and y direction, and our special starting point is right here in the middle. That's called the origin. And so these numbers right here, the 1 and the negative 3 and the 0 and x, tell me how far in the x direction I am from the origin. So this 1 means, so this is the positive x direction over here, and the negative x direction to the left. It's convention to write your arrows on just the positive directions. You don't have to, but that's somewhat standard. So the positive x direction is to the right, and the positive y direction is up, and negative, of course, is the opposite direction. So x equals 1 on the x-axis. So this is called the x-axis and the y-axis. X equals 1 on the x-axis is right here. And so this 1 and 3 means I should go positive 1 in the x direction and positive 3 in the y direction, and that'll be the point that I'm identifying. So positive 1 in the x direction, positive 3 in the y direction, and there's my point. Right, and then negative 3 in the x direction is 3 to the left, and negative 1 in the y direction is 1 down, and I've got a point there. And then 0, 2 means go 0 in the x direction, so don't move left or right at all, and then go 2 positive in the y direction, which is right here. Right, so I have 3 points, and I could pick more. I don't really need to, but it's certainly a thing that you could do. And I will just say, like, if you're not sure what the shape looks like, pick points until you know. This is a line, however, and the way you can tell it's a line, by the way, is that everything is to the first power. There's no squareds, there's no square roots, there's no weird other functions. It's just there's two variables, x and y, and they're both to the first power, and that's it. And everything like that is a straight line. So I don't know if I can draw this very well. I'm trying to do this on my computer screen, but there we go. Pretend that goes through all 3 points. So that line that I just drew includes all 3 of these points, or it would if I was better at drawing, You get the idea. And not only that, it's an infinite number of points, right? This is, if you think of this line as being made up of an infinite number of points, every one of these points is a solution to this equation, right? So this one right here is x equals -2, y equals 0, because it is 2 left of the origin and 0 up or down, right? So if x is -2, then -2 plus 2 is 0. And so -2, 0 is a point, or is a solution to the equation, and therefore it is also a point on our graph. And that's really what it means to graph something, is we literally can't write down all the solutions to this in this form because there's an infinite number. You would be writing forever. However, we can draw them all in this way. So that's what graphs are. They're visual representations of the solutions of equations, at least for our purposes. Don't tell any mathematicians I said that's what a graph is. But that's what they're going to be for us. And so we're going to learn basically 3 major kinds of graphs. This is by far the most important one. Lines are far and away the most important shape and type of equation in all of mathematics. It's not even close. We'll go into why at some point. We'll see them more often. But as you take other classes, you'll do things where linear functions, which this is called a linear function, model a lot of real world things, much more than anything else. Second place is probably exponential functions, which we will get to later on. We'll do those right before we do logarithms. And then after that, we also learn how to graph parabolas. Those are significantly less important, useful mathematically, but as far as real world things go, not so much. Okay, so lines, how do we graph them? This is one way. And for all the graphing we're going to learn, and there will be a moderate amount, because we're going to learn how to graph exponential functions and logarithmic functions and parabolas or quadratic functions. I'm trying to remember if there's anything else. I think there might not be anything else, but we'll do a lot of graphing. And I'll teach you some techniques for each of the functions and all that stuff. And the one thing that you should remember more than anything else with graphing is, if you don't know how to graph something, or you don't know what the graph looks like, just plot a lot of points until you do, and then connect the dots. That is the secret to graphing things that you don't know what they look like. If you don't know what something looks like, make a big old chart. 4 points is not enough, by the way. If you want to know what something looks like, make a chart of a lot of points, 10 or 15 points. Graph tons of points, and then when you're sure you've got the pattern, then graph it. That's very exhaustive, and you don't want to, that's not the best way to graph things, but it is the only way that always works. So if you don't know what something looks like, don't forget that you can always just plot a lot of points. That is the most general, although usually not the best way to do it. Okay, so I want to talk about lines and how we can identify that something is a line. So like I said, we want 2 variables, usually x and y, but they can be other things. You don't have to label your axes x and y, although I will refer to the horizontal axis as the x-axis and the vertical axis as the y-axis, because that's the most common way to label things. But if you're doing a word problem, it might be s and t, or something else. So you're looking for 2 variables, and both of those variables are to the first power, and nothing else is being done to them. And then everything else in the problem is a number. And if that's the case, you've got a line. So anything of that form. So the most general form of lines. So forms of lines. Forms of lines. You got your standard form, which is this form, ax plus by equals c. A, b, and c are numbers in general, by the way, for this class. Letters that are at the beginning of the alphabet tend to be constants, unless I specify otherwise. That's the case. Excuse me. And letters at the end of the alphabet, x, y, z, tend to be variables. Again, unless I say otherwise, that's the case. So this is a good general example here. The a, b, and c are numbers. The x and y are variables. There's the slope-intercept, which we're going to use a lot because it's really convenient. And we will talk about what those two terms mean. It's y equals mx plus b. And m, again, is a number. It represents the slope of the line, which we will see in a second. And then point slope form. Again, with the slope, which we will represent. I will explain what that is. And that is this one, y minus y1 equals m times x minus x1, where x1 and y1 are numbers, and I don't mean the ones. I mean this whole thing right here is a number, and the reason we're calling it y1 there is because it's a y value, but I don't want to call it y because my variable is called y. So I'll explain more about that when we get to there. But I want to explain a few of these terms, very specifically slope and intercept, because those are really important when you're graphing lines. So the slope of a line, actually, let me explain the intercepts first. Those are a little easier to show you. So intercepts. The x-axis, the y-axis, put arrows on the positive ends. And I'm not going to draw hash marks here because they're actually not very important. So picture a random line on this graph. So let's make it a different color so it doesn't look like the axes. There it is. There's my line. There's two really important points here with respect to the axes, which is where it hits them, right? So this line hits the axes here and here, and those are called the intercepts. So this is the y-intercept. Oops, excuse me. And it's obviously called that because that's where it hits the y-axis, where it intercepts the y-axis. And this is the x-intercept, of course. We don't know a lot about those. I deliberately didn't put any hash marks on here because I don't really know anything about that line, right? No equations, no nothing like that. However, I do know something about the intercepts, and the thing that I know is that when it crosses the axis, the x or the y-axis, one of the coordinates there is 0. Oh, and by the way, I should say a coordinate is like this is an x coordinate here. This is a y coordinate. So here at the y-intercept, remember what the coordinates represent is the x coordinates represent how far left or right of the origin you are, and the y coordinates represent how far above or below. This point is not left or right of the origin at all. It is very specifically directly above it, right? That's what being on the y-axis means, is that you're directly above the origin. Similarly, for the x-axis, it's not up or down from the origin. It's just left or right, in this case left. So what that means is I know one of the coordinates of the y-intercept is 0. Specifically, the x-coordinate is 0 because it's not left or right of the origin at all. So I know that this point is 0 something, but I don't know what the something is. Similarly, for the x-intercept, I know that this point is something 0. But I don't know what the something is, right? Because I didn't put any labels on here, right? So I don't know how far left or right of the origin it is, but I know how far up or down it is. That is to say, it's not up or down, right? It's on the same level as the origin. Same thing here, same thing for this one, left or right. We're going to use that idea to find our intercepts algebraically. So let me go ahead and do that. Let me pick a line here. So I'm just going to get the equation of a line. I'll do a nice easy one, right? Y equals 2x minus 1. That's not this line, by the way. This is just a separate line. So, maybe I should separate that off like that so it's clear that this line is not that line. So y equals 2x minus 1. I can find the x and y intercepts by using this idea. To find the y intercept, I know that x is 0. So what I can do is I can put in 0 for x and see what y has to be. So if I put in 0 for x, I get this. Y equals 2 times 0 minus 1. 2 times 0 is 0. Minus 1 is negative 1. Negative 1. So I would say that when x is 0, that means y has to be negative 1. So I would say that 0, negative 1 is the y-intercept. I'm just going to shorten that to int. Similarly, we can do the exact same thing for the x-intercept. Put in 0 for y this time, right? Because when we're looking at the x-intercept, we know that y is 0, but we don't know what x is, and that's what we're looking for. So I would say I'm going to put in 0 for y, and that's going to be, 2x minus 1. And now I can solve, right? I add 1 to both sides. 1 equals 2x. I divide by 2. X equals 1/2. And so I can say that 1/2, 0 is the x-intercept. So notice that the intercepts are points. So you want to identify them as points using our standard notation for points, which is, this is what's called an ordered pair. You just put in parentheses in the order of x, y. So whatever's on your horizontal axis, that's the thing that goes first. And whatever's on your vertical axis, that's the thing that goes second. So this point, 0, negative 1 is the y-intercept. That would be down here somewhere. And then 1/2, 0 is the x-intercept. That would be up here somewhere. That's how you find intercepts. You want the y-intercept, let x be 0. You want the x-intercept, let y be 0. That's it. Okay, let me talk about what slope means. So the slope of a line is its direction. So I can have a line that is very steep like this, or I could have a line that is pretty shallow like this, or I could have a line that goes down as you go to the right like this, or I could have a horizontal line or a vertical line. Right? There's all kinds of different directions you can have for your line. So here's how we define direction of lines. Each one of these is straight the whole time. So it never changes direction, right? It's the same, this line is the same direction over here as it is over there. So what we do is we define a number that is a ratio. It's the ratio of how much up it goes per unit to the right. And that's the slope. The slope is how steep is this, essentially, with bigger numbers meaning steeper and smaller numbers meaning shallower. Right? So this line is steeper than that line, so it's got a bigger slope. This line is negative. This line has a negative slope because it goes down as it goes to the right rather than up. And so that's what slope is. We often call this rise over run. I'm going to make a new picture because there are too many lines on that one. So let's say I have this this line right here, like that. That's not very straight. Let's try it again. And notice that I'm just picking any two random points on the line because it's the same direction everywhere. That's the run from here to here. This right here is the rise, how much it went up. So run is change in x. The rise here is the change in y. And when I say the change, what I mean is the change from one point to another on the line. And so our definition of slope is rise over run. It's the change in x, or change in y divided by change in x. By the way, the mathematical and scientific symbol for change in is a Greek D. It's a delta, which is just a triangle. It's not exactly like I think one of these sides should be thicker than the other, but I'm not going to bother. This is often written delta y, and this is written delta x. And so we say that slope is rise over run, or delta y over delta x. So let's see a couple of examples of this. So I'm going to pick 2 points. I hope you will agree with me that 2 points define a line. If I pick any 2 points, so point here, so let's not do it haphazardly. Let's try and do this nicely. And then we will do it very nicely on a computer. Well, I mean, this is on a computer, but I mean, I'll show you a computer graphing program that you can use. My favorite one, it's called Desmos. I'm going to pick 2 points. So I'm going to pick this point here, 1, 1. And then I'm going to pick, let's go like right here. So I'm going to go 2 to the right and 4 up, 2, 4. So like here. Oop. Something like that. So I have gone 2 to the right and 4 up to get from one point to the other, right? So my run is 2 and my rise is 4. So my slope, which we represent with the letter M, and I actually don't think anybody knows why. Different countries use different letters. US uses M. I think someone told me Sweden uses S, which makes much more sense. But so I would say that my slope is rise over run, or change in y over change in x. So that would be y changed by 4, right? It changed by positive 4 when I went left to right, and the x changed by 2. So 4 over 2 is 2. So that is what a line of a slope with a slope of 2 looks like, right? It goes up 2 for every 1 it goes to the right. And notice that if I had picked this point instead, right here, that's not a very good drawing, but this is the point 1, 1 is this one. This was the point I went up 4 and right 2. That means that this point is 3, 5, right? If I increased x by 2 and y by 4, then this point should be 3, 5, which it is. And then this point right here is I increased x by 1 and y by 2. And so that point is 2, 3, right here. Notice that we would have gotten exactly the same thing no matter which of these points we picked, right? So if I did 1, 1 and 2, 3, and those are 2 points, those are my 2 points on the line, well, then my y increased by 2, went from 1 to 3. My x increased by 1, went from 1 to 2, and I get m equals 2 over 1, which is still 2. And if I pick these, I get exactly the same thing. The x increased by 1, y increased by 2. So the slope is how much y changes if x increases by 1. So in other words, what is the change in y per unit change in x? That's what slope represents. So let me write that down. Slope is the change in y per unit change in x. And when you see that on a graph, what it looks like is how steep the line is. So those are really the same thing. How steep the line is, like the more steep the line is, the more y changes per unit change in x. That idea of slope is going to turn out to be super important. So what I want to do is I want to graph a couple of lines, make some points to you, then we're going to go fool around with Desmos. I'm going to show you a little bit about how to graph lines, then we're going to talk about the various forms of lines. So let me do this. I'm going to make this line So y equals x plus 2. We'll use that one we used before. I'm going to make this line y equals 2x plus 1. Don't want to do any. Sure, plus 1. Now I'm going to make that plus 2. And then y equals minus x plus 2. So we're going to find some, we're going to make an XY chart for each one of those, and we're going to graph all those. In fact, maybe I'll use Desmos to show you what those graphs look like. But y equals x plus 2. We've already made a chart for this, right? We made an XY chart, looks like this. I'm going to pick I picked my points kind of haphazardly before. I'm going to pick them more methodically here. -2, -1, 0, 1, 2. And now I want you to see what happens with the y's. So I picked points that are increasing by 1 around the origin, going from slightly to the left of the origin over to slightly to the right. Right? I picked things that are slightly negative up to things that are slightly positive. The y's here, when I put in -2 for x, -2 plus 2 is 0. So y is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. You might say to yourself, well, Jeff, that had an obvious pattern to it. It does, right? The x's went up by 1 and the y's went up by 1. So remember, the slope of the line is the change in y per unit change in x. And I made x change by 1. And when I say unit, by the way, I mean 1. So I made x change by 1 in each of these cases. And look what happened with y. When x increased by 1 here, y increased by 1. So I bet you know what the slope of this line is just based on the definition, right? Since the slope is how much y changes when x changes by 1, well, x changed by 1 and y changed by 1, so the slope is 1. Let's do this next one. So if I do x here, y there, I'm going to pick the same x values, -2, -1, 0, 1, 2. Here, when I put in -2 for x, I'll get 2 times -2 is -4, plus 2 is -2. Put in -1 for x, I get -2 plus 2 is 0. Put in 0, I get 2. Put in 1, I get 2 times 1 plus 2. So 2 times 1 is 2, plus 2 is 4. When I put in 2, 2 times 2 is 4, plus 2 is 6. So here, when x changed by 1, each jump from one number to the next is an increase of 1. The y's went up by 2, right? So from -1 to 0 is an increase of 1, but from 0 to 2 is an increase of 2. What that means is that the slope here is 2. Let's do this third one. So same thing, -2, -1, 0, 1, 2. When x is -2, I get minus a -2 is 2, plus 2 is 4. Now I got minus a -1 is 1, plus 2 is 3. This is 2. Put in 1, I get 1. I put in 2, I get 0. Now notice here what happened. When the x's increased by 1, the y's went down 1. They didn't go up. That's because the slope here is negative. That's what negative slope looks like. It's when x increases, y decreases. Now, if you're particularly sharp-eyed, you might have noticed that these m's here, the slope in each case, is the coefficient of x. It is, try again, there we go. Right here, there's a 1 and a 2, and this is -1. Those are the slopes. That is not a coincidence, but I do want to caution you that this only works because I have y equals something. If your line is in a different form, this won't necessarily be the slope. You have to get it into this form first before that makes any sense. So let's see what we're trying to do here. Oh, there was another thing I wanted to mention here, which is this. You might also have noticed that x equals 0 is the y-intercept. And that corresponded, so that was 2 in each of these cases. That was this number. That is also not a coincidence. So it turns out that when you have your line in the form y equals mx plus b is the usual lettering here. The coefficient in front of x is the slope, and the constant term here is the y-intercept. So if I go back a couple pages here, not there, not there, not there, this one. This form of the line is really convenient because you can just look at it and see the y-intercept and the slope, or I should say the y-coordinate of the y-intercept and the slope. So I'm going to flip over to Desmos a little, to show you some interesting stuff. Show you, well, one, Desmos. I think it's really interesting and really useful. Whereas there it is, Desmos. And two, to show you around lines a little bit. So this is an online graphing calculator. It's desmos.com/calculator. It is totally free. No ads, no nothing. It's great. I have no idea how they make money. And what you can do here is, obviously it's a graph, right? You can move this around. You can zoom in and out. And the reason I really like it is the following. So let me do this. If I write y equals 2x plus 2, right? This is the line that we just saw, that we were just using, right? That was my second line right there. And indeed, you can see that it is a little bit steep, right? Let me zoom in a little bit here. Yeah, there we go. It is kind of steep, but you can see right here, when the x changes by 1, y changes by 2. Y increases by 2 here. Now, the reason I wanted to show you Desmos is the following. If I write this equation, y equals, instead of numbers, I use letters, it will let me make sliders for them, which let me do this. Right? It currently has m set to 1, so the slope of 1, and b set to 1, which is the y-intercept, or at least so I have claimed. So let's see what happens when I change the y-intercept. It kind of looks like it's sliding perpendicular to the line, but it's not. It's just going straight up and down. Right? So when b is negative 2.2, we can see that the y-intercept is right here at negative 2.2. And when b is 2.9, we can see that the y-intercept is right here at 2.9, right, just below 3. Let me go put that back to 0. Now my y-intercept is 0, and it goes right through the origin. So you might ask yourself, what happens when we change m? Well, I've claimed that m is the slope of the line, that the steeper the line is, or the bigger the slope, the steeper the line is. So let's increase m a little bit. Right, as m goes up, you can see that the line is getting steeper and steeper. Right, and when m is 7, there's m equals 7, very steep, right? M equals 10, incredibly steep. And let's go down closer to 0, right? So as it gets close to 0, you can see the line flattens out. When m is 0, you can see the line's horizontal, right? So a horizontal line has a slope of 0. And a line with a negative slope goes down as you go to the right, which is the thing that we saw, right? Y decreases as x increases, right? So picture starting here at 0, 0, x increases by 1, y decreases by, that looks like 0.8 to me, right? And that's what the negative sign means. Negative sign means as you go to the right, y goes down instead of up. That's all negative slope means. Right? And so there you go. So that's what slope is. Slope is the direction of the line, and we define the direction of the line by how much y changes as you slide 1 unit to the right. Right? Increasing x by 1 is visually equivalent to sliding 1 unit to the right. So the question is, when we slide one unit to the right, what happens to the y value, right? Does it go up? Does it go down? How much does it go up or down, etc.? And you can imagine that we just hit that point again. If the slope is 0, right, I slide one unit to the right, and what happened to y? Nothing. It didn't change at all because the slope was 0, right? I went one unit to the right, and y didn't change. Y changed by 0. And so I get this line that's just straight left and right. Okay, so that's Desmos. Desmos is super useful. I will use this many times in these lectures when I'm trying to talk about some graph. I'm basically always going to go to Desmos because it is my favorite way to graph online. They have an app too, by the way. I don't mean to turn this into an ad for Desmos, but the app is free, no ads. It's the same thing. It has all the same functionality. Just look up Desmos app on Google Play Store or the Android, whatever that any other Android stores are, or the App Store. All right, so let me go back to here. Okay, so you might say to yourself, well, that's great, but how do I use that to graph a line? Well, let's see. Let's say I want to graph some line. I want to graph this line, y equals, let's say, minus 2x plus 3. Now, the first thing I want to notice is that we can, well, actually, the first thing I want to notice is this. If I don't know what that line looks like, I can just plot an XY chart. I just make an XY chart and plot the points and then draw the line that goes through them, and that will work. It is not the easiest way, and it is not the way that anybody who knows how to do this stuff does it, but it is a way, and it does work. So let me show you the good way to do this. So the good way to do this is to notice that I have this line in the form y equals mx plus b, where m is -2 and b is 3. And I know what those things mean, right? M is the slope and b is the y-intercept. So I can identify before I do anything what the slope and the y-intercept are, and that is enough to graph the line. I actually don't need anything else. And in fact, any point on the line plus a slope will do it for you. That's all the information you need. Let me show you why. All right, sorry for the dead air. My y-intercept has a y-coordinate of 3, and all y-intercepts have an x-coordinate of 0. So I know before I have to do any math, just by looking at it, I know that that point is a point on the line. In fact, I want to make this, let's undo that and make this blue. That point I just highlighted is a point on the line. And I know what the slope is, so I can find another point. Remember that slope is how much y changes when x increases by 1. Well, I have a point here. X increasing by 1 would mean I would go 1 to the right. And this -2 tells me that y changes by -2, so I go down 2. So if I go right 1 and down 2, I get this point right here, and that's enough, right? 2 points define a line, so I'll probably botch this, but oh no, that's pretty good. There's my line. Now, if you look in the module that I have for this topic, you'll see that I posted I think like 3 other videos or something like that. Almost every video that I found on YouTube talking about graphing lines did this. They just turned everything into this form and then graphed it, doing exactly what I just did. They identify the y-intercept, identify the slope, graph away. That's pretty good. Like, that'll work fine. And it's not bad advice to do that. I want to do something a little bit more complicated first, before I talk about what I actually do when I'm graphing lines, and it's not exactly the thing that I just described. But if you want to do it that way, that's totally fine. Nothing wrong with that. Let's see. Let's see another example here. So what if I do this? I'm going to do y equals, I'm going to make this a little bit harder by throwing in a fraction. Two-thirds x minus 1. Now, remember, I've defined slope actually in two different ways, which I hope wasn't too confusing, but I've defined it as the change in y when x changes by 1 unit, when x increases by 1 unit, right? Or I said if x increases by 1, y changes by the slope, in this case goes down 2, right? X goes 1, or we go 1 in the x direction and down 2 in the y direction. And that is true. That is a correct definition. But the definition you've probably most likely heard most often about slope is that it's rise over run, or change in y over change in x, which is also true. Turns out those are equivalent definitions. It is easiest to think of it like this when you have a fraction. I'll show you what I mean. So here I've got rise over run for my slope. Well, my rise is 2, my run is 3. And so when I'm doing my graphing here, so let's get my axes set up. By the way, get used to drawing a lot of these. You can make your homework much neater by just being good at making these. Ideally, better than me. So I'm not. I'm using my screen. So I got a touch screen on my laptop, and that's what I'm using to draw. And I'm just using my finger. So I hope it's legible. So I'm going to do the same thing that I did before. I have a y-intercept, or the y value of my y-intercept is -1, right? So I'm going to go down to 1 below the origin. And then I'm going to think of slope as rise over run. So rise is 2, run is 3. Run always, by the way, goes to the right. So run of 3, rise of 2. So I'm going to go 3 right, 1, 2, 3, and up 2, and end up right here. And I'll draw the line that goes through those 2 points. And that is my line. Now, the point I should make here, and I didn't do a great job of it, this kind of looks like I went right 1 and up 1. I actually, if I had drawn this better, you would see that I would go right 1 and up 2/3, right? So my slope is 2/3. In fact, let's go look at Desmos and see what that looks like on Desmos. Yeah, so I'm going to go ahead and turn these guys off and do this. If I say y equals 2/3 x minus 1, here we are. This is a better picture of it, of course, because it's drawn by a computer. And you can see y-intercept is -1, just like it was in the picture I drew by hand. And when I went to the right 1 unit, it doesn't go all the way up to 1. It only goes up to 2/3, right? So we can see that a little bit. Close enough. Or it goes up 2/3 up to -1/3, right? Because it started at -1. So I didn't go up a whole unit. And I did indeed, when I went to the right by 1 from here, this went, it went up 2/3 from here, right? It started at -1, up 2/3 to -1/3. So despite my picture not being perfect, the math works out just fine. So again, once you are in this form, once you are in slope-intercept form, and it's obviously called slope-intercept form because you can see the slope and the y-intercept, right? That's where it gets its name. Graphing is a breeze, right? You have a point for free. You have the y-intercept. This is the y-coordinate of that point, right? Here it's -1. Here it's +3. And then you've got the slope, and the slope tells you where to go from that point to get another point, right? Here it says go up 2 and right 3. So I went up 2 and right 3. Here it says go down 2 and right 1, right? So this is -2 over 1. -2 is, I hope that's clear that -2 is -2 over 1. And you can put any number you want over 1. So that means I'm going to go right 1 and down 2. So I went right 1 and down 2, and I got another point, and that's how I found my second point. And that, honestly, is kind of all there is to graphing lines if you are in slope-intercept form. So now, let me talk about how to get an equation into slope-intercept form. So I want to go back to, well, maybe I'll start fresh here. So slope-intercept form is this one, y equals mx plus b. And so the defining characteristic of this form is that y is alone, has no coefficients, and there's no more numbers over here either. X can have a coefficient, and then whatever numbers are left over go here. So let's do an example. So let's say I start with this equation, 4x plus 3y equals 6. That is not in slope-intercept form. It doesn't have any of those nice properties I was talking about. Like 6, despite being the only constant, and so you might think, oh, well, 6 goes with b because it's the only constant. Nope, b is not 6 in this line. The slope is the coefficient of x, so maybe that's 4. Nope, it's not that either. So this is not nice for graphing. To make it nice for graphing, you have to turn it into this form. What that means is I want to make this look like that by solving for y. I'm going to try to get y alone. So in the same way when you were solving linear equations before, what you were usually trying to do was solve for the variable, right? Whatever the variable was, we're going to get that alone. That's what we're going to do here too, but we're thinking of our variable as y. I mean, I know x is a variable as well, but y is the thing that we're trying to get alone. So that means I need to peel off all of the stuff that's not y and leave y itself alone, right? I'm just going to leave the y sitting here and get rid of everything else on that side to the other side. Now, since we are solving for something, we want to do SATMAP again. So remember, PEMDAS. PEMDAS is for simplifying, which is the opposite of what we're doing. We are solving. So we are going this direction here. So I'm trying to solve for y by getting y alone. So that means I'm going to get rid of everything that's not y, starting with the addition and subtraction, right? So the things on this side of the equation that are being added to or subtracted from our y is this term, 4x. That's the thing I got to get rid of first. So I'm going to subtract 4x from both sides first. You might say to yourself, well, how the heck do I do 6 minus 4x? Those things aren't even alike. Is that just 2x? No. That is 6 minus 4x. You can't do anything with those. Now, I'm going to make a sort of aesthetic decision here to write it in this form with the x's first and the numbers after. When I say the numbers, the constants, the things with no variables after. So I'm actually going to rewrite this as 3y equals minus 4x plus 6. And remember, this minus sign is not on the 6, it's on the 4, or it's on the 4x, right? The thing in front of the 6 is a plus, right? When there's nothing there, it's a plus. So I have plus 6 here and minus 4x, and I can write that in the other order. That's just fine. Addition you can do that with addition. So I'm not done yet because I don't just have y, right? This form has just y, no coefficients, nothing else. I need to have that first. So I'm going to divide both sides by 3. I'm currently multiplying by 3. I will divide by 3. That will give me y, right? The 3's cancel, equals minus 4x plus 6 over 3. You might say to yourself, well, that does not look like this. Minus 4x plus 6 over 3 does not look like mx plus b. There seem to be a lot of extra fractions in this thing, and there are. So what we're going to do is we're going to build on the idea of adding fractions, except we are going to unadd them in the following way. I'm going to go to an extra board here. So let's say I had 2/5 plus 7/5. I think you will agree with me that when I have a common denominator, I can just write them. I can write this as like 2 plus 7 over 5, which is 9/5. we're actually in this situation right now in the previous problem. I don't want to write it like this. I want to write it like that. So I'm going to take my two things that are being added over one denominator and split them up into two separate things over the same denominator, right? Normally we would start here and then we would go there, which is the normal thing to do, but it's totally legal to go backwards, right? It's not a thing you normally do, but it is a thing we're going to do now because it does the thing that we want it to do, right? So I'm going to write this as y equals minus 4x over 3 plus 6 over 3. Right, and I hope you can see that all I did was split that thing from the previous step up into two pieces, each over the same denominator. And then I'm going to rearrange this just a little bit to look like this. 6/3 is 2, right? 6 over 3 is 2. And now I have the form that I wanted, mx plus b. And this starting point, it isn't exactly as far away from slope-intercept form as you can get, but it's pretty far from slope-intercept form. But by keeping in mind that I wanted to just solve for y, I wanted to get y alone, that let me figure out what to do to get it into slope-intercept form, right? Peel off everything that's not y using the rules we already know for solving equations. So I have this equation now, y equals minus 4/3 x plus 2. Let's go ahead and graph that. So this one, y equals minus 4/3 x plus 2. Zoop, zoop. Okay, so my y-intercept has a y value of 2. My slope is negative 4/3. So that means I'm going to go from my starting point, which is my y-intercept in this case, I'm going to go right 3 and down 4. So let's do this in blue again. 0, 2, that's my y-intercept there because the b is 2. Then I'm going to go right 3 and down 4. So right 3, 1, 2, 3, and down 4, 2, 4. Down to here, like that. And as expected with a negative sloping line, goes down as we go to the right. Right, so there's my line. Let's go see what that looks like in Desmos, which is to say in a more precisely graphed arena. I'm going to turn that off and say y equals negative 4/3 x plus 2. So exactly what we had, right? Y-intercept of 0, 2. And then when we went, we would go down, right 3, down 4. So right 3, 1, 2, 3, and then down 4, 1, 2, 3, 4, down to here. Lo and behold, it's exactly where we thought it would be. Cool. So that is the basic idea of how to graph a line when it does not start in slope-intercept form. You can put it into slope-intercept form by using algebra, right? We just we got rid of everything that was not the y to get this into slope-intercept form, leaving just y equals something. Now, I rearranged it in a way that you might not have thought to do right here by putting the x's first and the numbers second. Feel free to do that because that's the way you want to end up, right? We want the x's first and the number second. So I just did that early. If you didn't happen to see that, you can do it later too, but do be aware that just because it's in the other order, like if I'd left it as 6 minus 4x, that doesn't mean that the 4 becomes b and the 6 becomes m. That's not the case. It's the coefficient of x, right? The thing that's in front of x, that ends up being your slope, right? The negative 4. The fact that it's in front of the x is the defining characteristic, not which order it comes in the equation. Okay, so let's graph another one that is less obvious, right? So let's say I have 3x minus 2 times y plus 1 equals 5 minus 4y plus x. And I think it's completely reasonable to say to yourself, that is not a line, right? I've got 2 x's and 2 y's. That doesn't look anything like the forms we've seen. That can't be a line. It is a line. Because remember, the defining characteristic of a line is there's only 2 variables. And when I say 2, I don't mean that they only occur twice, but that there are only 2 different ones, right? I've got x and y, and yeah, I have them each twice, but there's still only x's and y's. There's not like a z. And everything is to the first power, right? There's no powers on the x's or y's. So this actually is a line. This is the equation of a line. And I can't look at this and tell you what it looks like, right? I need to turn it into slope-intercept form first. So let's do that. So I'm just going to clean this up. And if you see something like this and you're lost about what to do first, stop for a second and say, okay, what's my goal? My goal is to get all the y's on the left side, just y on the left side, and everything else on the right side, right? I want y equals something, where that something we're going to put in the form mx plus b. So that's what I'm going to do. I'm going to try and, 1, get rid of all the parentheses. I'm going to distribute this -2, and don't forget it is negative, so it has to be, the negative gets distributed to both these things. Then I'm going to use algebra to move all the y's to the left and all the x's and numbers to the right, and then I'm going to rearrange stuff until it looks like y equals mx plus b. That's the plan. So with that in mind, it should become relatively easy to figure out what to do if you remember what the goal is, like what you're trying to make, essentially. So the thing I'm trying to make is y equals mx plus b, so let's start. So the first thing I'm going to do is I'm going to distribute this -2 to both those things, and we get 3x minus 2y. Minus 2 times 1 is -2. And one tip, by the way, when things get messy, don't try to do too much. Take more steps instead of trying to do more per step. It'll make your life a lot simpler. All right, now I mentioned that I wanted to get all the numbers and x's to the right and the y's to the left. You can do that in essentially any order you want. It really makes no difference at all. I'll move the numbers to the right, then I'll move the x's to the right, and then I'll move the y's to the left. +2, +2. Now, the placement I'm doing with the +2s, and I want to be very clear on this, it's a +2 on each side of the equal sign, right? I wouldn't put a +2, like a +2 here and then another +2 here, because I would be adding 2 on the left side twice and on the right side not at all. So the thing I want to do is I want to put a +2 on each side of the equal sign here. All right, so on the left side, the +2 and the -2 cancel out. On the right side, that's a +5 and a +2. Remember, that's not a -5, the minus is on the 4. On the left side, I have 3x minus 2y, and on the right side, I have 7 minus 4y plus x. And there's an equal sign in the middle. I'm going to get rid of that line. Some people like to draw a line there. That line always bugs me when it's there, so I'm gonna erase it. Let's get my pencil back. That's all. There we go. Equals. I'm still trying to keep the y's on the left and move the x's to the right. So I'll go ahead and move the x's that are currently on the left to the right. So minus 3x minus 3x, and I'm deliberately lining these things up under the like terms. Right, I'm lining my x up under another x. So 3x minus 3x cancel each other. I get minus 2y equals, well, x minus 3x is minus 2x. So I have 7 minus 4y minus 2x. All right, so this is looking good so far. This is definitely simpler than when I started. Now I want to get the y's to the left, so I don't want any y's on the right, right? Notice that there's no y's over here. So I'm going to move my 4y over to the left by adding 4y to both sides. And I think I'm going to need another board here. So minus 2 plus 4 is 2. So I have 2y. And on the right, I have 7 minus 2x. 7 minus 2x. I'm going to go ahead and start another board and rewrite that. So I got 2y equals 7 minus 2x. Now, I'm almost done here, but I want to do 2 things. I'm trying to match this form, y equals mx plus b. So I'm going to arrange it in this order with the x's first and the numbers second, and I'm going to try and get rid of this coefficient in front of the y. So I'll rearrange first. I think 2y equals minus 2x plus 7. And remember, the minus is on the 2, not the 7, right? So the minus goes with the 2x. The 7 has a plus sign in front of it because there's no minus there. All right, so I got 2y equals minus 2x plus 7, and then we're going to do the same thing that we did in the previous problem with the fraction. Divide by 2. Y equals, I'm going to write this as minus 2x over 2 plus 7 over 2. And then simplifying that a little bit, I get y equals, the 2's cancel, and I'm left with a minus 1. So I just have minus x plus 7 over 2. So here, it's not obvious what's necessarily what's in front of the x, but it's a 1, right? It's what the thing in front of the x is the thing that you are multiplying by x. So if I have, or there's actually a minus 1 here, I should say, not just 1. But what I was getting at was there's like a secret 1 there, right? And you can write it as minus 1x if you want to. That's not standard. The usual thing to do is not write the coefficient, which can be a little bit confusing if it's not a thing you're used to. But when you see just a variable, the thing you want to think is like this y right here. How many y's is that? Well, that's 1 y, right? There's the 1. This one up here, how many y's is this? That's 2 y's, because that's the coefficient. So it's very easy to think that this is a 0 here. It's not. When there's no coefficient written, that means it's a 1. And this one would be a negative 1 because there's a negative sign, of course. So let's graph this line now. The slope here is -1, and the y-intercept is 7/2. You might ask yourself, where is 7/2 on an axis, right? How big is that number? And this is where it would be helpful to turn that into a mixed number. I think it's probably a good idea to do that. And so we'll do that in just a second, because that'll help you know how big that number is and therefore where it goes on your Cartesian plane. So 7/2, the question you want to ask yourself is, how many times does 2 go into 7? 2 goes into 7 3 times with 1 left over. So this is 3/2. So I have y equals minus x plus 3/2. So that's where I'm going to go. I'm going to go up to a y-intercept of 3/2, or a y-coordinate 1, 2, 3 of the y-intercept of 3/2. Oh, I should do that in blue. Right here. And it's got a slope of -1. So that means I'm going to go right 1 and down 1. So right 1, down 1. Now, one thing that you might notice here is when I'm graphing this, it's actually a little bit easier to graph if the points aren't too close together, right? If they're very close together, you have to be extremely precise with how you are drawing your line. If your line is like just a little bit off, it'll get a lot off as you go farther out. So what I'm going to do is, instead of going down 1 and right 1, I'm going to go down 2 and right 2. You could also do down 3 and right 3, or down 4 and right 4. Or in this case, what would actually be a really easy thing to do is to go down 3/2 and right 3/2. Right? That actually works fine. If you do 1 and 1, that's totally fine. Well, I'm going to do the 3/2 thing real quick. Whoops, did that not? There it goes. And then we're going to draw the line between them. Oh, here's a tip for you, by the way, that a member of the math club taught me. I'm the advisor for the math club, or at least I am when we're on campus. And one of the members of the math club was a really good artist, probably still is. And she taught me and the rest of the club how to draw a straight line, which is a really interesting thing. So I will go here. If you're looking to draw a line, or looking to draw a straight line, what you want to do, like let's say I want a line that goes from here to here, Like it's way over there. What you don't want to do is look at where your pencil is. What you want to do is look at where it's going. So I'm going to put my pencil, which is my finger in this case, on my screen at the first dot, and then I'm going to look at the second dot and draw towards it. And I'm going to miss, embarrassingly, but notice that my line is nice and straight, and it's actually quite easy, easier than I made it look here. Quite easy to hit your line. So look where you're going, not where you are. That's the secret to drawing a nice straight line, especially over a long distance. Like if you have 2 points that are pretty close together, it's not that hard to hit them both as I miss. It's not that hard to get them both. But if you have 2 points that are a long way apart, it's surprisingly tough. Try it on a board sometime. Try it on a whiteboard or a chalkboard if they're even still on campus. Or even just all the way across a piece of paper, right? Line on one side or dot on one side, dot on the other side, try to draw a line between them and start with like looking at your pencil the whole way versus put your pencil on the first line and then look where it's going and just draw. The second one turns out to be significantly easier, which is pretty interesting. I really like that tip. So just a little drawing tip from Daisy O'Mahony, who you've probably never met before, but she was an excellent artist who was in the math club. So there's my line. Notice that if I went down 1 and right 1, that would work fine. If I had gone down 2 and right 2, that would work fine, right? I would hit the line. At least if I had drawn it well, I would have. And so as long as you're going, as long as the two things that you are, the two numbers you're using are in the right ratio, it works. Yeah, I'll just leave it at that. So that is graphing lines. Now, I've given you enough information here that you can graph pretty much whatever line you want. Whatever form you start in, you simply put it into slope-intercept form. This one, right? So if I start in standard form like I did in the first one I was solving, I just put it in the slope-intercept form, and I use the y-intercept and the slope to graph the line. Or if you're starting in this other form here, this one, by the way, this point slope form, super useful. We're going to talk about this in a second. If you're starting in this form, you just distribute the m and get the y on one side and all the numbers and x's on the other side, and you're in slope-intercept form and you graph the line. That always works. That almost, I'll show you a weird case where it doesn't work, but that essentially always works. And that, like, if that's what you do to graph lines, that is fine. It'll get you through this class. I will show you what I actually do to graph lines, which depends on the form they start in. And I need to tell you a couple of things about, or I need to tell you a couple of ideas about the other forms. So let me talk about standard form, which is by far the worst of these. It's significantly harder to graph a line in this form than the other two, but I'll show you the easy way that I like to do it. So let's just 2x plus 3y equals 6. 3y equals 6. There's a nice line. So here's what I'm going to do. I'm not, oh, by the way, this thing that I'm about to show you, completely optional. You don't have to do this. I like it. I think it's easier than transforming into slope-intercept form. But if you want to skip this, it's fine. So here's what I'm going to do. I'm going to use the fact that all I need is 2 points on the line in order to graph it, right? The line is defined by 2 points. If I have 2 points, there's only one line that goes through it. It's the line I want. So here's the way I'm going to do that. I'm going to find the intercepts of this line. I'm going to find the x-intercept and the y-intercept. And in this form, it's particularly easy to do. So that's why I'm doing it. And what you'll find is being good at math is partly being good at calculations and knowing stuff, but a lot of it is tricks that make things easier. So what I'm going to do, and remember to find the intercepts, if I want to find the x-intercept, I let y be 0. I want to find the y-intercept, I let x be 0. I'm going to let x be 0 for one of the points, and I'm going to let y be 0 for the other one. And all I have to do is find the corresponding points or the corresponding numbers, and it's actually very easy. Because I don't know if you remember way back at the beginning of the video, I said, if you have the opportunity to pick 0, pick 0 because it's usually the easiest. Here you go. If x is 0, that means that this term right here, when I plug in 0 for x, 2 times 0 is 0. I can essentially just ignore that term. And then all I have to do is solve 3y equals 6. Well, that's easy. That means y equals 2, right? I just divide both sides by 3. Same thing. Oh, shoot. 2. And then I do the same thing with y. Let y be 0. This term goes to 0, and you get 2x equals 6, so x is 3. I have 2 points. That's all I need. If x is 0, y is 2, so my y-intercept is 0, 2. My x-intercept is 3, 0. And there's my line. I'm done. Hey, I graphed it. Now, what you can't see here is the slope, right? It doesn't appear. And the y-intercept doesn't appear here either. The fact that this is a 2 and that's a 2 and this is a 3 and that's a 3, it's actually a coincidence. I probably should have picked different numbers, but those things do not match up like you might hope they do. So my y-intercept is 0, 2, and my x-intercept is 3, 0. And we can find the slope, right? If I go down 2, I go right 3, so that means my slope is negative 2/3, which is true, but we didn't need to know that in order to graph the line. All I needed was 2 points, and I found them by finding the intercepts, which is relatively easy. So that's how I like to graph lines that start in standard form, rather than turning them into y equals mx plus b form. So there you go, just a little tip for you. There's another form of a line called point slope form. So a point, if we have a point, x1, y1. And a slope m, slope m. Then an equation of the line through the point, through the given point, I should say, with the given slope is y minus y1 equals m times x minus x1. That is a little bit long-winded and a little bit mathy, but it's true. And this turns out to be super useful. If you go significantly farther in math, like you get up to math 200, which is vector calculus, which some of you probably will. Like if you want to be an engineer, for instance, you'll have to go that far and farther. This idea of arranging a line like this is really helpful. It's really, really useful. And when we do word problems, this is the form of the line that we're going to be using most often, actually. So let's see what this looks like. So let's say I have, now this is quite similar to y equals mx plus b, right? It's got y on the left side, mx, or got an m and an x on the right side. The rest of it looks, is a little bit different, but in general looks kind of similar to slope-intercept form. And this m is the slope of the line. It's just that b isn't here, right? And we've instead substituted a different point on the line. Now let me point something out. I wish I could click through this a little quicker. forgot what I was going to say, shoot. Oh yes, for a slope-intercept form, the B here is the y-intercept, right? Which is a point on the line. It's a very specific point on the line that we can always identify. Point slope form is great because you don't have to have the y-intercept. You can just have any old point on the line, right? Much more general. So the any old point on the line is x1, y1. So let's see what that looks like. So if I have point, let's say 2, 3, my slope, not the slop, the slope, let's say m equals -1/4. I can find the equation of the line even though that's all I know. So this is x1, this is y1. So I'm going to just use the form y minus y1 equals m times x minus x1. So the x and the y are variables. Those are the x and the y that are going to end up in our final line. Y1 and x1 are the numbers, well, x1 is 2, y1 is 3, and m is the number -1/4. So what I have here is y minus 3 equals -1/4 times x minus 2. And that is the equation of the line. Now we could stop there, and in fact, it is very easy to graph this line. And I'll go ahead and do that, and then we'll put it into slope-intercept form afterwards and see what it looks like. So graph this. 1, 2, 3, 4, 5. 2, 3, 4, 5. I'm going to start at the point 2, 3 because we have said that that's a point on the line. So 2, 3 is right here. I didn't draw that 3 very well, but whatever. You get the idea. There's 2, 3, and it's got a slope of -1/4. What that means is the rise is, I'm thinking of the rise as -1 and the run as 4, right? I'm always running to the right. And then the rise is, if it's positive, we go up, and if it's negative, we go down. So if I go 4 to the right, I should have gone 1 more here. 1, 2, 3, 4, yeah. Like if I go 4 to the right, I would go 1 down. So there we go. I should have been doing this in blue all along, but that's okay. And there we go. So notice, I didn't have to put this into slope-intercept form in order to graph it. And in fact, just from looking at the picture, I actually don't know what the y-intercept is. The way I've drawn it, it kind of looks like 4, but I bet it's not with this fraction. I bet it's some fraction. But I was still able to graph it because point slope form gives you a point and a slope. So if I started with something in this form and recognized this is point slope form, right? I would say that x1 must be 2 because I have x minus x1. I've got x minus 2 here. And y1 must be 3 because I've got y minus y1 and y minus 3, right? So x1 is 2 and y1 is 3. So I know 2, 3 is on the line. And I know the slope is -1/4. So I go down 1 and right 4. And there we go. That's my line, right? So I don't actually need to start at the y-intercept. I can start anywhere as long as I know some point on the line. Let's go ahead and put this into slope-intercept form and see what it looks like. So we're going to do the same thing that we've done before. I'm going to get the y's alone. I'm going to distribute all the numbers and get everything on the right and looking like mx plus b. So first thing to do, distribute that -1/4. So y minus 3 equals -1/4 x. And -1/4 times -2. Let's go off to the side and do that. Right, -1/4 times -2. Let me show you how I am doing this problem. The first thing I'm going to do is ignore the negative signs. I know I've got a negative times a negative, so it's going to come out to be positive. So I can just, while I'm doing the problem, not think about them. And because that will make the problem easier, that's what I'm going to do. I just have to know ahead of time that's going to happen. It's going to be plus here. And I've got 1/4 times 2. Now, this integer, I'm going to think of it as 2 over 1. And then when I multiply, I'm going to cancel, right? 2 and the 4 cancel and leave me with a 1 and a 2 here. So this is a half. So I got negative 1/4 x plus a half. Now that 1/2 doesn't look like this number over, it doesn't look like this, right? 1/2 would be down here. And the reason it doesn't look like that is because I'm not done, right? I have stuff over on the left side that I have to get rid of first. So you have to get all the way to y equals mx plus b if you want to be able to identify the slope and the y-intercept easily. Kind of running into stuff here. So I'm going to get y equals minus 1/4 x plus, now we could turn this into fractions if we wanted to, but I'm just going to write it as 3.5, since that's going to be the convenient number that we would want to use anyway. So yeah, lo and behold, it kind of looked like it was 4, but it's just because my line was bad. It's actually 3.5. It's right here, right? That's where the y-intercept should be. So I can put this into slope-intercept form, but I don't really need to, because if I recognize that it's in point-slope form, it's actually easier to just stop right here and graph it, right? I've got a point, I've got the slope, that's all I need. Okay. Last thing I'm going to talk about is vertical and horizontal lines. So sometimes what you get is a line that looks like, let's say this, y equals 4. You might say to yourself, Jeff, that is not a line. You said that a line has 2 variables, right? It's got an x and a y, and that clearly only has 1 variable. So this is not a line. Turns out it is, actually. So what I'm going to do is I'm going to make an XY chart for this line, using the idea that all I know about the line is that for all the points on it, y is 4. Every point on this line has y equals 4. So since I don't have any x's in the equation, x can be whatever I want. So if x is 0, well, then y is 4. If x is negative 3, y is 4. What if x was 1? Y would be 4. So let's do this guy in blue. I should have done the chart in blue, but that's all right. So whoop, I didn't put hash marks. Let's try it again. Hash marks. 1, 2, 3, 4, 5. Oh, that's not the best hash marks I've ever made. It'll be okay though. Oh, funny. The other ones are pretty neat, but not the ones I want. Okay, so if x is 0, y is 4. And if x was negative 3, y was 4. And if x was 1, y was 4. And since y is 4 at all of these, right, the height, remember that y is your height. So since y is always the same, the height of the line at every point is the same. So it's horizontal. Similarly, if I have the equation x equals something, let's do x equals 2. We'll do negative 2. The same thing is going to happen, right? All I know about the points on this line is that x is negative 2 for all of them, but y can be anything I want because I don't have any y's, so I get to freely choose it. So if x is negative 2, y is 0, so that's this point over here. If x is negative 2, y could be 3. That would be this point here. If x is negative 2, y could be negative 1. That would be this point. And I think you can see where this is going. So your horizontal lines look like y equals something, and your vertical lines look like x equals something. If you are missing a variable, you have one of these, right? So if we are let me give you an example here. Let's do a quick problem here like this. Let's say I had a line that was this graph. 2 2 plus 3 times x minus 5 plus y equals 2y plus 3x minus 1. Right, so let's say I have that messy thing that I want to graph. All right, let's do it. I think it's clear from the this equation that it is a line. Everything's first power. Nothing is we've only got the two variables. We're not doing any square roots or trig or anything weird like that. So let's just let's simplify this and see what we get. So I'm going to get 2 plus 3x minus 15 plus y equals 2y plus 3x minus 1. I'm getting all my y's on the left and the x's on the right. So let's get the x's on the right, and I'll combine the 2 and the negative 15 while I'm here. So this is going to be, well, no, let's do it. Let me go slower. We're going to have 3x minus 13 plus y equals 2y plus 3x minus 1. Sorry, I just wanted to get to the good stuff quicker. So let's do what I did before. Move the numbers over. I'll add 13 to both sides. 3x plus y equals 2y plus 3x plus 12. And we're going to move all the x's to the right. I'm going to get y equals 2y. Well, 3x minus 3x here are 0 plus 12. Then I'm going to get all the y's to the left, so I'm going to subtract 2y. And I need a new page. But I think you can see what's going to happen. You've probably noticed already that there aren't any more x's. So it turns out that this complicated, messy looking thing was a horizontal line the whole time. It's y equals negative 12 because all the x's went away. So what happened here is that I had the same amount of x's on both sides, positive 3 x's on both sides. And so they were canceling each other out, right? If I have positive 3x on the left and positive 3x on the right, those are not, like if I pick an x value, it adds the same thing or subtracts the same thing from both sides. So that's why they cancel out like this. And so it's entirely possible to get a line like this, or a line that doesn't look horizontal or vertical. And by the way, I could have done the exact same thing with the y's, and then what we'd have was a vertical line instead. But it's entirely possible to get one of the variables to cancel out, and then what you've got is a horizontal or vertical line. If I wanted to graph this, there's no need to pick points or try to identify a slope or anything like that. What you really want to do is just memorize. Remember, y equals a number, horizontal. X equals a number, vertical. The thing you really want to remember there is, if you're memorizing that, is it's backwards from what you probably think, right? Because x's is the horizontal axis, so you'd think, well, okay, if I get x equals negative 2, that must mean a horizontal line at negative 2. It does not mean that. It means the opposite of that. It means a vertical line at negative 2. And the reason it means a vertical line is that if I know that x equals negative 2, that means that horizontally we are fixed. The horizontal distance is always negative 2. So whatever point I pick on the line has an x of negative 2. But the y can be anything I want. It can vary freely because it's not in the equation. So because there's no y's here, I can go up and down as much as I want. But because the x is fixed, I can't move left or right at all. I'm stuck at negative 2. So this thing is horizontal, or excuse me, this thing is vertical, and this thing is horizontal, which is probably backwards from what your intuition suggests. So this line, this y equals negative 12, is a horizontal line at negative 12. So I'm not going to draw in all my hash marks here, but I'm just going to say that that's negative 12 right there. So this is the line y equals negative 12. Right, and you could put in some hash marks that don't feel like drawing 12 right now. And there you go. And the same thing for vertical lines. If the y's go away, you get x equals something that's a vertical line. And I think that is where I want to stop with graphing lines. Now, let me just sum up a little bit. The number one thing I want you to remember about graphing anything is if you forget how to do it, right, which is entirely possible on a test, for instance, a thing that always works is to just pick a lot of points. 4 is not a lot. I picked 4 because I know what this looks like. If you didn't know what it looks like, pick more. There are 3 forms of lines that we'll use: standard form, slope-intercept form, point-slope form. Standard form kind of stinks, not that helpful, but it is relatively easy to graph in this if you find the intercepts. Slope-intercept form is probably the easiest one to read and the easiest one to graph from. You have your slope and your y-intercept just sitting there for you waiting. And point-slope form is actually the most useful of these when doing problems. And we'll see this when we get to word problems. We don't have to worry about it right now, but this form is super, super useful. This is the one we want to use most of the time. And this is the easiest one to graph with. So we'll use a lot of slope-intercept and point-slope form. For graphing purposes, slope-intercept is probably a little bit better. For usefulness purposes, point-slope form is definitely better. Standard form, we'll actually use this a little bit, but not in this context. The intercepts are where your line crosses the x and y axes. If you want to find your y-intercept, let x be 0. You want to find your x-intercept, let y be 0. And then solve for the other one, right? So when I was looking for my y-intercept here, I let x be 0, found my y-intercept. When I was solving for the x-intercept, I let y be 0, solve for x. Slope is this. It is how much y changes per unit change in x. Or you can also think of it as what is as rise over run, right? Change in y over change in x. Those actually mean the same thing. Sometimes it'll be easier to think of it as how much y changes per unit change in x. Sometimes it is easier to think of it as change in y over change in x. Both of those are fine. Again, slope is the change in y per unit change in x. And then graphing lines, right? So your b is the y coordinate of your y-intercept. M is your slope. And so you can identify your y-intercept, 0, 3, and then use your slope of -2, meaning I go down 2, right 1, to get another point, and then graph. Same things here. So here it's easiest to think of this as unit change change in y per unit change in x. So y changes by -2 when per unit change in x. So if x increases by 1, then y goes down by 2. Here, it's probably easiest to think of it as rise over run, right? Rise is 2, run is 3. I've got my y-intercept of 0, -1, so 0, -1. And I go rise 2, so up 2, run 3, so right 3, so up 2, right 3, get another point, draw my line. One common way to graph lines, and a pretty good one, to be honest, is to just put everything into slope-intercept form, which essentially means solve for y, right? Get y alone. And when you're doing that, you're solving as opposed to simplifying. So you're not doing PEMDAS, you are doing SADMAP, right? We're going backwards. So that's what I do. I get rid of the addition first, and then I get rid of the division second. And then when you get to this point, it doesn't necessarily look like y equals mx plus b. So you might want to split it up into 2 pieces, right? They're both over 3. So I'm going to break this into -4x over 3 and 6 over 3 separately. And then sort of rearrange, just kind of put the x out front here. So we get -4/3 x is my slope, or -4/3 is my slope. The x is not part of the slope. And then 6 over 3 is my y-intercept. And I use that to graph my line, like this. Then we do the same thing here, right? This is a messier looking line, so you have to clean it up first. That's what algebra is for. So we clean it up, right? I get all my y's on the left, my x's and numbers on the right. And after a little bit of work, I end up here. Y equals -x plus 7/2. I turn the 7/2 into a mixed number, 3.5, because that's easier to plot. And I have a slope of -1 and a y-intercept of 3.5. So I go up to 3.5 here. go down 1, right 1, or I actually went down 3.5, right 3.5, which also works. Quick way to graph lines in standard form, find the intercepts. Intercepts are typically quite easy to find in standard form, right? You let x be 0, and then this term, or this term is 0, and so we just ignore it, and so we get 3y equals 6, so y equals 2. Same thing the other way around, right? We let y be 0, solve for x is 3, and then you have 2 points and you graph your line. Point slope form, super useful. A little hard to understand, but super useful. This is our point, x1, y1, and that appears here and here in the formula. M is still the slope, x and y are x and y, there are variables. So if you get a line in this form, it means that x1, y1 is a point on your line, right? So if instead of saying that I started with a point and a slope, I said, graph this line, what you might do is you might say, aha, I recognize that as point slope form with an x1 of 2 and a y1 of 3. So I know the point 2, 3 is on the line, and I know the slope is -1/4, and so I can graph. That does work. You can also just put it into slope-intercept form. That's totally fine. Horizontal and vertical lines. Y equals something is a horizontal line. I know it looks vertical, but it's not. It's horizontal. X equals something is a vertical line. And the something is where it goes through. So the x equals -2 is a vertical line through -2. Y equals 4 is a horizontal line through 4. And horizontal and vertical lines are not necessarily obvious from just looking at them, right? If you just started with this thing, you would probably not think to yourself, well, that's clearly a horizontal line. Turns out it is. You just have to do some simplification first, so got to clean it up. And that is all I want to say about lines for now. You should be able to graph lines pretty easily. And of course, as always, come see me if you have any questions, and I will see you guys in the next video. So let me go ahead and stop sharing this and end the recording. Yeah, I will see you guys in the next video.